Hello YouTube and welcome to my channel. Today I'm going to be talking about the factory method and the abstract factory design patterns in C++. I don't know if this video will be too long. If that will be the case, then I will break it into two parts. So in the first part I will be talking about the factory method, and in the second part I will be talking about the abstract factory, but we will see. So I have already created a C++ project in Visual Studio Community Edition. I'm going to create a new item, a C++ file that I'm going to call by convention main. So, right, and as usual, I will include the IO stream, and I will be using stdc out. Come on. And L. So int argc car pointer argv and I'll return for starter 0 and I'll just output some phrase hello design patterns to see if this thing is working. So let's build. Oh yeah, I know why is this. I have a problem on my platform. I need to add the certain directory here, which is, I don't know why it's not being found by itself automatically, but I hope this won't be a problem. Microsoft Visual Studio 2007 community SDK. I think this guy live. Let me check this out again. Rebuild. Yep. So now if I put a breakpoint here and I say start debugging, I see the program runs, so there is no problem here. So I can stop debugging and continue working. So what we are going to do is now we are going to add a header file. I will explain why. So the header file will be called, let's say, vehicle, and I'm going to add another header file which will be called the factory. Okay, now I'm going to explain exactly why is this all about. What is this? So basically, supposedly you have a class hierarchy like this. Okay, you have a class called vehicle, from which you subclass into another class which is called motorcycle. Then you have a civil car that is also of class vehicle, and from this class, from civil car, you have probably another subclass called sedan, etc., etc. You could probably have a military vehicle here, and from that you could have like a Humvee or a tank or whatever. This is a typical class hierarchy. There is nothing extraordinary here. What you're going to do, the factory method is this. You have another class hierarchy that is called the factory, Okay, and okay, and this class will have two static variable methods that are responsible for creating and destroying your instances, your vehicle instances. The point of this is that let me check. I would create it like this. Okay, let's say like this, for example, and you will create an instance of type vehicle. Okay. So this is the point of this factory. Two things. First, your client user doesn't know until the time of running what kind of instance he or she wants. This is the first thing. So what are you going to do is that you will be deferring the moment of instantiation until the runtime. This is the first thing. The second thing is you don't want your user client to be able to create instances wherever he or she wants, or destroy them for that matter. You want to concentrate the place where the instances can be created or destroyed into only one or two places. And for that, what you're going to do is you're going to create a class hierarchy of your product, which is the vehicle, okay, with private or protected constructors and destructors. In that case, of course, you will make the factory a friend of those classes, okay? In this case, the client user will not be able to create instances of your class hierarchy freely, okay? He will be limited to accessing the creation process from the factory method, which I'm going to demonstrate in a second. So for example, let's say you have a class called vehicle, okay, and you have protected vehicle. Okay, this is the constructor. It is protected. You will have a virtual destructor, of course. Okay. And you will have a public interface, of course, which will, I don't know, void virtual void do run, for example, or execute, or whatever you want to call it. This is the public interface that is going to be run through your class hierarchy. Okay, so we will create another class, which is, let's say, civil car, and which will be subclassing publicly the vehicle class. So, and here I'm going to put again the constructor as protected, okay, and the destructor as well. So in this case, I'm going, of course, also incorporate the public interface here. You will run. Since vehicle is an abstract class, you don't need actually to instantiate anything from it. You will be instantiating only the subclasses. So now I need another subclass for demonstration purposes. Let's say it's a motorcycle. then it will also publicly inherit vehicle. So motorcycle constructor. You don't need to incorporate the virtual keyword every time in your subclasses, but it's for the destructor or for the public interface, but it is a good habit to do so. I mean, in big class hierarchies, when the user sees this keyword, it's easier for him to understand the relationships inside. Okay, so motorcycle, oops, like this. Okay, and of course the public interface, which is run. Okay, so I think I have that. Yeah, okay, so I'll go to the factory class. For this, I'm going to say class factory, and I will have two public methods which are static, okay, and I'm going to call them create instance of certain type, let's say I, okay, static, probably int, destroy instance of pointer type. Okay, I need to include, of course, the type, so it's include vehicle.h. Okay, yep, looks okay. So here is the thing. When you want to create an instance of vehicle, okay, you want to tell the class hierarchy or the factory actually what type of vehicle you want to create, and you will know that when you will need that instance to be created. So you will supply a identifier or a number or whatever you want, could be a string for example, okay, that will tell the factory what type of vehicle to create. For this purpose, I'm going to create two consts, could be enumeration, could be whatever, but I'm going to use const. So let's say civil car equals 1 and const int motorcycle equals 2. Okay, so now it's time to create the implementation files. So I'm going to create a vehicle, okay, and of course the factory. So okay, so in the vehicle I'm going to include the vehicle, and yeah, of course I will be needing also the IO stream using standard cout using std and l. And now, so constructor, all the three interfaces need to be implemented. So vehicle, okay, oops, the destructor needs to be implemented, and of course the public interface. Oh, you don't need that because it's virtual. Okay, so now it's the civil car, I think. Yep. So civil car, the constructor needs to be implemented. And let's say something, for example, civil car constructor called, okay, civil car, now the destructor, again, civil car destructor is called, okay, and the public interface, civil car do run, and we'll say something like civil car is starting slowly, or whatever you want to. Now this is civil car, okay, so now the motorcycle, so motorcycle, same thing as with civil car, see out, motorcycle constructor is called, motorcycle destructor, okay, motorcycle destructor is called, so, and the public interface, of course, which is, yeah, motorcycle do run, see out, so motorcycle goes on full and scares everyone, okay, so so this is the implementation of the vehicle. As for the factory, include factory, include vehicle, I think it should be, like that, okay. So now I have a static method called create instance, which is factory create instance. It takes an int, vehicle type, for example, okay. Now here you make your test. Okay, if vehicle type is single car V type. Okay, so if the user is demanding a civil car, then we are going to return a new civil car. That's it. That's all there is. What does it want? Is inaccessible. Okay, that's because I didn't include the friendship clause. So friend class factory, and here, oops, and here I need to make a forward declaration like this. So friend class factory, and this guy will be a friend with every subclass. Okay, so it will have access to their constructors and destructors. Okay, so it's okay now. Else if motorcycle equals v type, then return new motorcycle. Now, if neither of those were supplied, then return a null pointer. Okay, so this is how you create an instance. Your client user will not be able to create an instance by themselves. They will have to go to this method and ask it nicely to provide them with an instance of type vehicle. They will supply the type they need. Okay, now as for destroying the instance, we will do something factory vehicle pointer p. Okay, we will test if p is a valid pointer. Okay, if yes, well, we will be deleting p and setting it to null pointer, so it's not being used inadvertently. Otherwise, yeah, we will be returning 0 on success. Else we will be returning, let's say, -1. I mean, this is something that needs further investigation in your code if you're going to use this the destroy instance method, because usually it's the responsibility of the client user to ensure that the pointer that he or she needs to destroy is valid. But in any case, let's say that we are providing an error check by ourselves. Okay, so I think this is it for the implementation. Yeah, we could now try the code. So let's include the vehicle, and let's include the factory. I'll remove this. Now we are going to declare a pointer p of type vehicle, and we are going to call factory. Okay, and we are going to call create instance, and now let's say that we are going to call it for let's create a car for now. Okay, if the pointer that we have received is valid, okay, let's try what it will say to us. Okay, now I'm going to create another pointer of type vehicle as well, and I'm going to call the factory to create an instance of motorcycle. And again, we are going to test the validity of this pointer and see what happens. Okay, and after that I'm going to delete, actually let's say the result is factory destroy instance, and let it be p at first. Oops. Sorry, that shouldn't have happened. Okay, and q after that. Okay, let's say cout destroying p result and l, and now cout destroying q, and let's see what we will be having here. Okay, so I think we are done. Let's try to build the application. Whoa, it built. That's even suspicious. Okay, so I'll be running the application and see what will happen. Okay. All right. So first is a civil car is constructor is called, and since we are asking it to run or to do its business, then we have civil car is starting slowly. Okay, then the motorcycle constructor is called, which is here. Okay, and the motorcycle goes on full and scares everyone, which is this. After that, destroying p, the civil car destructor is called because of this. Okay, and the result is 0. Then the motorcycle destructor is called, and the result is of course as well 0. So this actually is the first part of the factory method. This is the factory method. The abstract factory is something a bit different, but I'm going to talk about it in the next video, probably very soon. So see you then. Thank you.